Good afternoon, everyone, and welcome to today's webinar, Revit Making Design Assist Schedules. And as always, I will try and keep an eye out on any questions that come in. If you want to type them in at the bottom, I'll try and remember to look there. So today we're talking about schedules within Revit. It's going to be a pretty short PowerPoint followed by some demonstrations. Hopefully you'll be able to get some good information out of it. But as we know, Revit is nothing more than a giant database that contains all the information that we place within our families and an additional 2D and 3D geometry. So schedules are really powerful because we can actually pull data out of our families and we can run calculations. We can embed additional schedules for more functionality. We can throw in some conditional formatting that is going to highlight problems or anything else that we want to sort of show. Parameters with formulas within our families. If we're applying a formula in our family, those formulas cannot be changed within the project. You would have to edit your family in order to do that. So with that, I'm going to jump into Revit. And here I've got a piping schedule. And these can be used to give us our flow and also a volume. So if we're looking at domestic hot water, as long as the piping system is properly modeled, well connected, capped where it needs to be capped, basically built exactly the way that we would out in the field, we're going to be able to pull some information out of there. For instance, like a hydronic supply system. We can use that 12.1 gallons for volume of our pipe to give us an indication about how big we might need to make a expansion tank, sorry. So if we take a closer look at what we've got here, we can go into our fields. And for this particular one, we're going to have system classification, and our schedules are set up so that all of these are our headers, and from top to bottom they go left to right. So in this particular one, I've got system classification and then what type we'll be using, whether it be domestic cold water, fire protection, natural gas, sanitary sewer. The abbreviation that we're using to tag that particular piping system, the system name. So if you have multiple types of hydronic supply systems, they're going to get different names. We can also schedule the fixture units from, say, our sanitary systems or our domestic systems. And then if we're getting a GPM for those particular systems, those are being calculated with our fixture units being calculated into GPM for those systems that have it. And then there are other systems that'll pop up as not computed if they aren't completely modeled correctly. So if they have an open end or something, it's not going to be able to give us the proper flow. And again, as I mentioned, we have volume, so we can size expansion tanks or boiler sizes, what have you. We can also throw in static pressure and the number of elements that are within each of those systems. Now, over here in our available fields, these are all the available fields for piping systems. So we can pull any of that information back and forth. If we're using fluid density, for instance, for a computation on, say, delta T's or something, we could bring those over and incorporate those as well. Now, if we look at, say, a duct schedule, we can do the same thing here, just isolate it by system classification and type, and we can put in, it's reading our flow, and again, if we have 0 CFM, that might be a good indication that either anything that's attached to that is currently set at 0 CFM, or you have an open duct end. We can also read the static pressure of that system, and then how many elements are within it. And let's see if we go on to the gas loads. And I know I mentioned in some of my previous webinars that there are master units for some of the units. And here we're showing gas flow CFH. There really is no CFH available. So if we were to take a look at this, we're using piping flow. And if I come up here and say highlight and model, we'll go to that particular unit. So we've got our air handling unit 3. If I scroll all the way down, you'll see here's my gas pipe flow. It's being calculated, and that's given a GPM. So we are sort of fudging the system, but if we were to edit that family and take a look at it, you'll see that, let me grab that and bring it over. If we go down to our mechanical gas pipe, it's in here somewhere, flow, we're actually using our formulas from the load input divided by the gas-fired heat exchanger fuel heating value divided by a constant in order to bring that value back into what we would use for CFH versus GPM. And again, as long as you have your parameters set up in your families, if they're set up to shared parameters, then you can schedule all of this information. So you'll notice, if we go back to our gas load summary, that I can't change any of these values, and that's because they're all calculated values. We saw that in our family. And then these are the inputs. So we could change our BTU inputs depending on the type of gas we're using. Are we using natural gas, or are we using propane? and we'd divide this gas flow, or divide the gas load input by the heating value, and we'd get our CFH. Now, one of my favorite ones is the a space airflow summary, and we'll also be looking at a lighting airflow summary, or lighting summary. So within here, I can see my entire space. I've got this broken up into spaces on the top here, and then everything below that is an embedded schedule for my air terminals. So I can look at entry number 1 is 478 square feet. Currently, I have an actual airflow of 500 CFM. My calculated was 473, so I'm off by 6%. And this is one of those conditional statements or conditional formatting applied to this particular field. If we take a look at our formatting tab, so our supply airflow check, difference, we can change our heading to be whatever we want it to be. Check our conditional formatting, and it's going to look at the difference of this supply airflow check to be not between -5 and 5. And if it's outside of that range, give it a background color of red. Currently, we can only put one conditional statement at a time into each one of these. So it's we can't compare certain values against other values unless we start adding additional parameters within our fields. We could actually add calculated values to say, comparing a couple of others. Let's just throw one in. So down in our formula, we can hit the 3 little buttons, pick area, and we can take our area, divide that by 1, because we want to make it unitless. And then, let's see, think of another one, actual. And we'll divide that one by 1 as well. I think I went the wrong way on that. Let's go back to switch that around. And you'll see that Revit puts in all of the required units in order to get the correct units to come out at the end. Let's try that. Okay. Boy. Try that again. Try and force it to do square feet. See if it kept it. It did. There we go. So So now we're calculating our area, our CFM per square foot, and it's given us 1.04. We can actually take a look at that conditional statement and highlight our actual. If we go under formatting, actual, conditional statement, we can point to that new value and say if it's not between, greater than, or less than, we can go from, say, 0.9 and 1.25. Yeah, 1.1. Say OK and OK. So this value is actually looking at these values and is going to highlight it if it's outside of the range that we specify. So we can use these as a quick indication of where we might need to look. Green was probably a poor choice, but we can utilize this to say, okay, I realize that I'm probably not at the right CFM. And maybe I need to bump this storage space up if I'm looking for 1 CFM per square foot. You know, maybe I need to bump that particular air terminal up. And if I'm ever curious about which air terminal this particular one is, I can just highlight in the model, brings me right to it, highlights it, and I can make my changes here. So if we've got our entire schedule and somebody has come through and given us our loads for each of the space, how many CFM, we can quickly come through and change these individually within minutes to have everything resized. That's a little big. There we go. And one more. And then down here we've got our returns. We could actually put some CFM on these as well. Now, one of the other aspects that we have, the lighting schedule. Oh, not that one. And I seem to have lost it. Okay. So what we can do with light fixtures is calculate all of them. Let's see. Take a look if I have one here. Nope. Well, let's make one. So we can come under our schedules and quantities. We want to go down to spaces. New construction, set our phase. Oh. Now when you're creating your schedules, you may run across some issues where you have a lot of similar, let's see, where's loads? A lot of similar parameters. Not just similar, but actually identical. So we can do apparent load or actual load. I'm trying to find some duplicates that are that one. But we'll start off with the name and number. Select those, move them up. And then when we're done with that, we can actually come under the embedded schedule and add our light fixtures and click the embedded schedule properties. And we want the family type. And you'll notice we have a ton of information we can pull in, from number of poles to circuiting information, what panel is it attached to, switch IDs. So if you have rooms with multiple switched circuits, you can show which ones are on which. Here, I'm going to hit cancel real quick. Because I found it. So you can see I've got my actual lights load, and that's based upon the information that the space is seeing. So if I come over and say grab my community room, highlight and model, I'm going to go to that space. I don't see my lights in this view, but I can see I've got average estimated illumination based upon the light fixtures I actually do have in the room. Here's my actual lighting load. If I go to my first floor lighting plan, there's my space, there are my lights. And spaces carry so much information. Here we can see our CFM. We've got our supply airflow here. Area, perimeter, volume. We can schedule this, put it in calculations. We can see what zone the space is being applied to. So we can have, if it's constant volume, we can show the zone for the piece of equipment. Or if it's broken up into several, maybe the space gets 2 zones. And then we have our heating and cooling calculations that are being brought in as well. But back to our light schedule. So we've got 57 volt amps, 29 watts based upon this particular family. 120 volts. These are not circuited yet, but we can see we have a specified lighting load of 1200 watts, and we're not quite there. So maybe I would bump this up to a little bit bigger light fixture. This is just a 2x2, but we're looking for about a watt per square foot. So if I went in and changed these particular fixtures, tab over, there we go. And we change these to maybe a 2x4. Thought I had one in here. Nope. But we can change our real power to 120 watts, changes our VA. The other thing about light fixtures to remember is that they have photometric web information. So set your IES files appropriately. So for this one, I've got it set up as a 2x2. Maybe I want to change it to 2x3 or 2x2 3 lamp. Have it applied there. Say OK. Now we can take a look at our 197. Our lighting load went up based upon our watts. So if we went back, wrong way. All of this stuff is showing up in our schedule. And we can compare our specified lighting load that we're looking for to what we're actually putting in here. So are there any questions? That's really all there is to it. We can just remember that your families have to have the parameters in order to schedule them, and anything that you schedule with a calculation in it in the family cannot be changed. So good luck. Thank you for attending.